And as stated, we are right now going to discuss with you the green transition in the shipping industry with methanol. The expression has been dropped also a couple of times right now. And as a starting point also for you to give us your questions for the discussion, I will start with an intro statement that we have received. And the intro statement is as follows. Hydrogen is a core element of a future decarbonized energy system. If the world's nations and also if the world's companies are to meet their climate pledges, the production of green hydrogen and derivatives such as e-methanol for the shipping industry must be massively scaled up to industrial levels. Also clear message here that you have shared with us. Of course, there is a steep increase on the demand side, and we need to, in parallel, also build up capacities to do so. Can you maybe, from your point of view, elaborate a little bit on this statement and also put your companies into connection with the statement? Claes, do you want to start? Yeah?
I can start.
Okay.
I mean, we see a huge growth in the needs of converting the shipping industry.
Mm-hmm.
I mean, the shipping industry consumes about 300 million tons of fuel on a yearly basis, and that needs to be converted by 2050. And we've got number 3 there. So we have to get all that done in the next 25 years. And today, about 1% or a bit less than 1% is fossil-free fuel in the shipping industry. But what we do see, which you can see on the slide here, is
we cannot see the slide. Do you want us to see the slide?
That would be useful, yeah?
That would be useful, of course. So then we need to ask the tech team. There we have the slide. Okay, good.
We're showing a slide here of a concept ship from Maersk, which is one of their first methanol-powered ships. And as you can see, there's in the order books today already of the shipyards, the equivalent of 7 million tons of fuel required that will be delivered by 2026, 2027. So those 7 million tons need to be produced by us and others who make this fuel. And that's a fairly large volume because for producing 1 million tons of methanol, you need about 1/6 of hydrogen in weight.
Okay. So, and how are you going to do this?
I'm going to ask him. Yeah.
Thank you. First of all, thank you very much for having us here at this very esteemed panel and forum. At Siemens Energy, hydrogen is one of our core elements to drive the energy transition. And we are really glad that we are able to have great partners like Liquid Wind. And I will also maybe jump to the next slide to explain a little bit on the concept, how we are driving this green energy transition. So we have a concept developed, and thanks to also great colleagues like Engelbert and others who do that for years now, to combine a group of experts in the green methanol arena, together with us as the experts on the electrolyzer system, to produce green methanol or have a process to produce green methanol based on our electrolyzer design, which is a PEM system. And we also want to show you today that this is not only something that is a vision for us, but it's already a reality. So we are putting this concept, which we call the flagship concept, already into action, and it's in execution. And what you see here, when you were referring to the large amount of e-methanol that is required already for the decarbonization, this setup that you see here on the screen can already produce 50,000 tons of e-methanol a year, and we will further scale it to the double of the size of it, which is equivalent, if you look at our electrolyzer size, this one is 70 megawatt, and then we have to develop the next one with 140 megawatts. And with this, we aim to achieve the targets that Claes mentioned on decarbonizing the shipping industry. And maybe, Claes, you can guide us a little bit more through the whole process and setup
Of course. And maybe, Claes, just because I just see that there is a question, where do you get the CO2 from?
Absolutely.
And while you're presenting this, maybe you can address this question right away.
Yeah, so we started 6 years ago as a developer, so the one who puts all the pieces together to enable an investment decision and then the execution of one or many projects. And when we started, we collected, if you will, experts in electrolyzer technology, carbon capture, and methanol reactors. And we made a selection process over about a year's time, where we then found our core team with Siemens Energy, Topsoe, and Carbon Clean. And that is what we today call the Liquid Wind family. And we've now been working together for 5 years to get to a complete project that can then be executed. And to your point on the biogenic CO2, we then went to look all over Sweden to see where can we find good biogenic CO2. And you can see here, we actually have quite a few pulp mills and quite a few CHP plants that run on biomass. So we went to see which ones of those would be most suitable. And for the first project, we found one in Örnsköldsvik, which is about halfway up the coast in Sweden, so around here somewhere. And then we design it in such a way that we put our plant right on the facility where the existing CHP plant is, and then we connect to the stack from there, and we pull the CO2 out, we purify the CO2, we produce the hydrogen locally there, and we then make the methanol all in one location. So this whole thing came together, and then we needed to find an investor, and then we went out also in the world to see who we could find. But Ørsted became our investor in the first project. So late last year, we sold the project to Ørsted, and then there was an investment decision, and then we've also had the groundbreaking ceremony quite recently.
Thank you very much, Claes. And we have one question, which is about what is the price per ton of e-methanol produced in the liquid wind facilities?
This is, of course, a very good question, and it's not one that I will share. But the price of methanol needs to be reduced. I think the gentleman before us here said that it will always, I didn't say that, but it is more expensive today than fossil fuel. And it both is because we have to manufacture it, and I think even it should be because it's a better product. But the main component of the methanol price is the electricity. And in Sweden, we have low cost or relatively low cost electricity. So we are in a favorable position with the electricity price. And then we have, if you will, the same tools and technology as more or less everyone else has, but we try to integrate it tighter and be a little bit smarter in how we build it. So we believe we are the lowest cost methanol producer in Europe. And as I said, I'm not going to give the price away because it's not public information. Yeah. But I can also say in the next facility we do, it will be cheaper. And in the third one we do, it will be still lower cost, which is the intent. And we plan to be at price parity by 2030. So if you take fossil fuel plus CO2 taxes, and then we will kind of come from the other side down. So somewhere in 2030, we hope to be price parity.
Okay, good. So, I mean, we have already talked about the steep increase on the demand side, and I mean, we have also seen the diagram and your initial statements, but how easy is it to ramp up the production capacity with regards to electrolyzers?
Maybe I can take that one. I mean, for us, what is very crucial is, on the one hand, the standardization that we do in the project, so that we have a reference, we have a blueprint. That is what we call this flagship concept that we can always repeat, so that we can limit the efforts. And the same is also true for our factory. So when we do electrolyzer production, right now we are at an automation level in our factory of roughly 50%, but we will soon move here to Berlin to a new facility, which will be almost fully automated. So it's 90% automation. And with that, of course, not only the quality is much higher, but also the ability to produce much more stacks in the same time is higher. So we go to a gigawatt scale of production, and everything, let's say, that is also behind that, the engineering tools, the standardization, allows us to start this steep ramp up.
I see. Okay. Where is this facility going to be?
It's in Huttenstraße. It's not a
Okay,
secret. It's
okay,
our
yeah.
gas turbine factory.
Yes,
we have a
yes.
lot of huge
Yes.
turbine halls already here in Berlin, and we freed up one hall from our gas turbine facility to produce our electrolyzer, PEM electrolyzers there, because we have the full infrastructure. So we have the logistics there, we have
Perfect.
quality management, manufacturing. So we are putting it into an existing system that is also de-risking it, let's say, for ourselves and for our customers.
Perfect. Very, very good. Really in the heart of Berlin. Very traditional manufacturing facility. Yes.
From
Yes,
our
please.
side, when we scale up, so instead of building a bigger factory, we would build multiple factories. And so our first one is 50,000 tons or 60 million liters. The second one will be twice that size, so 130 million liters. And then we will do units of those. So we will standardize around that size and make it very efficient to produce that size. And we even put a modularization system when we manufacture it, so we can very quickly execute. And if we needed a big capacity, we could have 2 times 100 or 3 times 100. But that's the way we see it, rather than building gigawatt factories that are going to take a long time to finance and a long time to get going. We like this sort of cookie cutter concept.
Okay, thank you very much, Claes. We have another question here, which has been raised by Anonymous, and Anonymous asked, why do you use methanol and not synthetic methane or E&G for the shipping or shipping fuel?
For the simple reason that methanol is a liquid in its natural state, and it can therefore replace other liquid fuels one-to-one. It's much easier to do that than to try to get into the gaseous phase. Okay. So we can use liquids on ships, we can use liquids on trucks, trains, wherever you want to go, because we're all used to liquids. So for us, we think the methanol is a better space. And as I think we sometimes say, the methanol contains more hydrogen than liquid hydrogen because of the way the chemistry works. So it's a very efficient means of moving hydrogen around.
Okay, very good, very good. Perfect. So you have shared with us the diagram, and you also referred to current projects. My next question is, what are the next e-methanol projects that you have on the agenda? Maybe you can guide us into a future projection, what we are going to expect in the near future.
If we can.
Now we need to go back to the slides, yes?
Yeah, so we have, as we stand right now, 2 more projects in Sweden that we're working on. They're in the same region as the other one. One is just north, so one is up here roughly, and one is a little bit south. So we'll have 3 collected there that will all be ready for delivery between 2025 and 26. And then we have a pipeline of another 5 or 6 between Sweden and Finland. And then we will continue to grow after that, both in the Nordics and then possibly in the US that we like to talk about. The IRA concept or the IRA model is going to be useful for us, and that's one possibility for us. But for now, we are in the lead in the Nordics, and we want to keep that lead and make sure we build as many plants as possible.
Okay.
Because it is a challenge to get these kind of across the line, and therefore we want to make sure that we continue on the good momentum that we can see here. We've actually done one. We've done it essentially without any government grants, and we've done it sort of on market-based pricing. So we want to continue to do that, and yeah, keep the speed up.
Thank you, Claes. Nima, something to add on?
Yeah, we are also, of course, having other projects beside these flagship projects in our development, and there are also a lot of larger scale projects that will take a little bit more time. So, I mean, the big advantage that we have now here also with Claes and the Liquid Wind team is that we move really quickly, and you have the full infrastructure available. Like Claes mentioned, you have the biogenic CO2, you have the grid connection. It's also easier to finance a project of 70 megawatt size or 140 megawatt size rather than gigawatt scale big production capacity. But nevertheless, of course, we know that there are very interesting prospects in the US, in Chile, where you have excellent conditions also for producing these e-fuels. And we also, in parallel, of course, also look into those opportunities. But for now, we think to move quickly and deploy it soon. This is the concept we go for.
Good stuff. Very, very good.